Today we are working on a Sony XBR-65X900E 65-inch. This is the power board out of it. It's not the power brick. This type of TV doesn't have actual power board to it. It actually uses a power brick, and then it uses this to convert the rest of the voltages. So we've got 24 volts input, and off of that 24 volts that the power brick gives us, this board then converts that 24 volts to all the other voltages that the TV needs. So you've got this chip here should be the chip that converts that to all the other voltages that you need. And I've already checked this board, and we do have 24 volts coming in. We've got 24 volts on these three capacitors, 0 on these three, 0 on this one, 0 on this entire half of the board, and we've got 24 volts on 2 of the pins on this and nothing on the rest. So I'm thinking that something is wrong with this circuit here, but we're going to have to see what we can find out. So let's get started. First thing we're going to do is we're going to inject our 24 volts into it, and I'm just going to see. I'm going to start this off with trying to see whether anything is shorted on the board. And the easiest way to do that, rather than mess around with my multimeter and figure out what exactly is shorted on the board, if there is anything, I'm just going to use the thermal camera, because that's the easiest way to do it. So put this on the fuse there, like that. And we're going to put this on negative. Okay, you can see that that we're drawing a little bit of power here. Let me raise up the amperage here, and it should shoot up to 24. There we go. Okay, so it's at 24 volts, 0 amps, nothing at all for amperage, but we're at 24 volts. Okay, so now that we're getting power there, let me break out the actually here. We've got power there. Let me give let's see here. Okay, so we've got power. This capacitor, oh wait, here, voltage. There we go. That's what we need. So that should be ground, yep. This should be positive, and we've got, okay, we've got 24 volts there. This should be ground. This should be positive. We've got 24 volts. This should be ground, and this should be positive. And we've got 24 volts. Check this one, 24, this one, 24, this one, that one we've got 24. Okay, on our MOSFET here, we've got 11.73 coming in. We've got 24 out. Got 24 on this side. All of these are 24. Okay, so we've got 11 coming in on the gate. And we've got 24 on the other side as well. Okay, so that MOSFET is working. Check this diode here, that's 24. Capacitors, 24, 24, and that's the input from that. Okay, we've got some resistors over here on this side of the board. 24, all these should be 24. Yeah, those are all 24, okay. Now, on this side of the board is where we have our issue. This whole side. This capacitor, we have nothing at all. 0. These capacitors, we've got 2.175. Dropping. Slowly dropping, okay. 2.15, let's say. Okay, And that looks like it's coming off of these 3 pins on this chip. Let me bring out the, it'd be easier for you guys to see what I'm doing here if I take out the, let's do this, scope. Okay, this is what we're looking at here. We've got these capacitors here. All of these, we've got 2.13 on these capacitors, which, as you can tell from where this is laid out on the board here, it should be coming from these 3 pins right here. These should be 2.13, 2.115. Okay. Do we have anything on this side of the chip? Doesn't look like there's any pins on that side. Okay. So these should also be the 2.1. Yep, that's 2.1. Okay, looks like there might be... What are these? Got nothing here. Oh, that one's got 0.4. Okay, do we have anything on these capacitors? We've got nothing. Nothing. Okay, nothing on any of these. So this should be ground. This should be ground, because if this is positive on these capacitors, this should be ground. So this, let's just verify that. We'll go into, yep, okay, so that's ground. So then on this side we should have some kind of voltage, and we've got almost nothing, 0.02, which means we've got nothing on this coil. And that coil should run through here, and that should be outputting off of these pins. And we've got nothing. Nothing. We've got nothing on any of this. What about this? Nope. This? Nope. These? No. No. And no. Okay, so that means none of this is going to have anything either. What about these? Okay, there we've got 24 volts. And we've got 17, and 11. That runs to this side. So we got 24 on one side, 11 on the other. And that is feeding this. 11. 11. That's feeding this. 11. And we've got 24 on the output of that. 20. So we got two 24s there. Wait a second. That, should that be 24? This is 24. But this runs, if we trace that back, that runs to here. And this is, I guess that is 24. Okay. Alright, what do we have here? 11. 3.9. That looks like it runs to the ground plane there. Okay. It's 24. 0. 0. 0. 24, 0, and then there's nothing else over there. Okay. I'm thinking this is our issue. I feel like we should have voltage off of these two pins and this one pin, and we don't. And we don't have anything off of any of these pins, actually. Nothing. This should be here, we've got nothing. This should be here, we've got nothing. This should be here, we've got nothing. This is nothing, this is nothing, this is nothing. I'm betting this is our issue. What is the ACTN7E12? So it's an ACTN chip. Let me see if I can find a pinout for that. ACTN. ACTN. I'm not seeing anything for ACTN. Interesting. Okay. Okay, well, I just so happen to have a XBR 55-inch, basically the exact same TV in a 55-inch instead of a 65-inch. I just so happen to have the exact same board. It's not exactly the same. It uses a different voltage for the input, but it just so happens to have that same chip on it, as you can see here. We've got the same ACTN chip. Different numbers, but this should be basically identical. If you look at the difference between these, it's basically identical. You've got 4 capacitors on the top, 5 on the bottom, 2 small ones, and then the ACTN chip. 4 on top, 5 on bottom, 2 small ones, ACTN. You've got a resistor, a capacitor, vertical, and then 2 resistors horizontal. Same on this. You've got that little circuit down there, right here. It's basically identical, it looks like. So what I can do is I can use this as my pinout because it should be the same chip. It's the ACTN chip. So let's lower this down to, I believe this TV runs at 19.5 volts instead of 24. So we'll lower that down to 19.5. And this should be our main input here. Okay. Alright, we should be getting 19.5 here. Yep, we are. Okay. 19.4 should be good enough. Alright, let's see what we have here. So this should be ground. This should be 19.5. Or, sorry, 2.1 on the other board. On this one it is 1.5, but rising. On the other one it was 2.1 and falling. So it might level out about 2.2-ish. So that should be these pins. Yep, 1.9. Do these have any voltage? No. No. And no. This has nothing. Did these have voltage? No. Interesting. I know this board is good as well. I have tested this one, it works. But we've got nothing. So maybe that's just how that board is designed. I wonder whether they're using all of these pins here to send the main, 24, 19.5 volts to the main board, and then from the main board, it's only requesting different voltages off of this circuit if you press the power button. Could be how it's made. So rather than just always having this chip on, putting out different voltages, that when you press the power button, that activates this chip. I wonder if that's how they're doing that. Or activates this MOSFET, maybe? What is this? This isn't a MOSFET, is it? What is this one? Yes, it is MOSFET. So we've got our gate, which is not on. We've got nothing on that side, and nothing on this side. I wonder if that's how they're doing it. I know that this board is good. I've taken it out of a working TV. So to have something like this be exactly the same issue as that other board it's got to be just the design of it. Well, let's see. We've got a thermal camera, so let's give it a shot. Alright, let's set up the thermal camera and see what's going on here, whether that regulator rectifier is actually doing anything, or if it's just sitting unused until the mainboard requests from it. Let's see. Alright, thermal on. Alright, so we've got the thermal image there. And the thermal image is right here. So let's see what we've got here. So there's the capacitors. Now you would think if this chip was on here, that chip is right here, where my tweezers are here. You would think if that was on, that it would be getting warm right now. But it's not, which makes me think that it's not on. Now let's try the other board. The one that we thought was bad, which might not actually be the case. Plug in our 24 volts, which is actually only at 19 right now, so we need to raise that up. There's 24. And what are we getting here? And it's not getting warm. Let me grab my tweezers here. That chip would be right here. Just below that square that you can see here. Chip would be right here. And it's not even getting warm. So it's not turning on. So yeah, my guess is that what they're doing on this board is... Ooh, what's this? Oh, that's just metal. Oh. My guess is what they're doing is that it's just putting the 24 volts through to the main board. And that 24 volts on the main board is used to power things like the power button and maybe some other like small circuitry on that board, that when you press the power button, it then sends a signal back to this board that requests different voltages. So this board only puts out 24 volts until the main board is hooked up and asks this board to supply it with different voltages. And that's probably what this chip does, is that once the main board asks for it, this chip activates. And I mean, it's possible, I could trace back some pins on this board, but it's possible that they're using this MOSFET up here to, if they're using maybe this circuit up here to have the gate connected directly to the main board through one of these pins, and then that would allow the main board to control this MOSFET directly, and this MOSFET might supply the right voltage to this to then turn it on. That's my guess. Unfortunately, I don't have the whole TV here, so I can't test it with the main board that came with it. But what I do have is this cable off of this other power board I've got is the same cable that comes with that TV. So it just so happens that I can plug in this cable to it, and it just so happens that I've got the main board out of a 55-inch TV, which is exactly the same model number. Really, the only difference between the 65 and the 55-inch ones of these boards is this power board. It's the only difference between them. So what I can do is I can plug this in to the main board, and then I can input some voltage to it and see what's happening. So you can see now it's drawing a little bit of amperage, just a little bit, kind of on and off. So let's see. That chip is still not getting hot though. That chip would be right here. Still no heat coming off of it. Is there anything on this board that's getting warm? Possibly. No, I'm not seeing anything getting warm on the main board. It all looks normal. Okay. Well, let's give this a shot with the original power board for this TV and see what happens then. So we'll drop this back down to 19.5. Got our input there. Okay, so we got 19.5. We're plugged in to the TV. Let's see what we have here. I don't see anything getting warm on the power board. Don't see anything getting warm on the main board. That would be this area here. trying to think. If there's a way to turn this on. I don't think there is. Let me check some voltages here. Now that we've actually got this plugged into something. Let's see what we got here. 0. These are all 0. That's 0. That's 0. These are still 0. That's 3.8. Okay. 3.8. What is this? Okay. These should be 19.5, and they are. This runs under here. So this should get, is this, maybe this is positive off of this cap. So this should be 0, if that's what that is. 0, that should also be 0. This runs to that, which I didn't find anything on. If this is anything like the other board, all of these will be 0 except for 2 of them. I think these two will be 19.5. Oh, that's 0. 0. Actually, all of these are 0. No voltage on any of them. Interesting. Let me check on this board. 0.09. Okay. There's our 19.5. That one's also, yep, that one's 19.5. The rest of them are probably 0. Oh, there's 0.5. Where does that run to? That runs over to this little Texas Instruments microcontroller. Interesting. Well, I'm not having any luck finding the issue, but then again, I also don't have the correct board here. This is actually working off of a known good board, and I still can't really trace down how that works. My only thought is, my original thought there, which is that the main board, when you press the power button, requests like 5 and 3.3 and all that stuff from this power board circuit. And the only reason it's not working for me is because I don't have a power button to turn that on, which I might have. I might have a power button somewhere. What they're using for a power button, it might be kind of hard to show you here, but there's this main connector, and this runs into the Wi-Fi chip, the Bluetooth chip, the LED, the main power LED, the power button, the volume button, the channel button. It's all run through the same thing, and you can see it's a double-sided. It's got pins on this side and on this side. So really, without the power button, it's almost impossible to figure out, first of all, whether the thing's even on, because even if you were to bridge some pins to turn it on, you wouldn't actually know whether it's on, because it doesn't have a fan or anything that you can watch spin. All it's got is the main LED, and I have no idea where the pins would be for that. So I'm gonna go see if I can find a a power button board for this thing. Maybe I can test this a little further by getting it to turn on that way. My guess is that I'm not going to be able to test this, however, this original board, because this has a 24 volt input on it. And that board, even though it's the same model number, it uses a different input board for the 55-inch TV. And because of that, it really only has 19.5 volts coming into it, not 24. And I'm wondering whether this board is really, even though it's the same model number and everything, I wonder whether it's set up to support 24 volt input, or whether it won't work on 24 volt input and it only works on 19.5 volt input. Not sure. I'm also not sure why they would use the same board if, or why you would use a different board, a different power board. Why do you need 24 volt input instead of 19.5 if you're going to use the same main board? Why wouldn't you just stick with 19.5? That doesn't really make a whole lot of sense to me. But this is Sony we're talking about. I'm going to go see if I can find a power board, and I'll be back.